Alright, so factor and solve. So we did this in chapter 1 when we were talking about quadratics, but now we're talking about polynomials, which means my exponents have greatly increased, okay? But it's still the same concept. Remember that concept where if we're multiplying some things together, it doesn't matter what these things are. I'm even going to add an extra piece now. If you multiply them together to give you 0, then one or more of them has to be 0, right? So the key, we still have to make sure it equals 0 before we start. Yes. We're still going to make it equal 0, but now we're going to factor completely by any means that we have. And I gave you that sheet Friday. So we're going to have to look for all sorts of patterns. We're going to have to look for grouping. We're going to have to look for sum and difference of two cubes, difference of two squares, quadratic form, all those special patterns that we're going to have to look for because now we're not dealing with just simple quadratics. Yes? And then once we get it factored completely, same deal, we're going to set each piece equal to 0 and solve it. Okay. Let's say I have, this will be a fun one, 2x to the 5th plus 24x equals 14x cubed. So remember the first things first, I always make it equal 0 when I'm solving, okay? Because I got to figure out some way to kind of chunk this thing in pieces so that I can solve it from there. So to make it equal 0, I'm going to move the 14x cubed over because it's always a good idea to keep your leading coefficient positive if you can. Which one's the leading coefficient, by the way? 2x to the 5th because that's the biggest exponent, okay? So I move the 14x cubed over and I'm going to put it in the middle just so that it keeps standard form. And so now I need to go through the steps I know to factor. And on your sheet, there's even some reminders down at the bottom. Yes, you always want to check for GCF first to see if you...
Keep it up there, please. Come on.
To see if you can take something out. So what's your GCF here?
2x.
2x. What's left?
X cubed.
Close. X to the 4th. Minus...
7x squared.
So what is x to the 4th called?
X to the 4th.
That's
Yeah.
it?
Yep.
So I can't say x
No.
quadruple?
All right. So now the question is, can I factor this down any further? Probably. Abby, put that away, please. Quadratic form. It's definitely quadratic form. Abby. So I know that because the first exponent is even, the middle exponent is half the first, and then the last term is a constant. Yes?
Correct X.
The first exponent, the biggest exponent's even. The middle exponent's half of the first, and the last term is a constant. That's quadratic form. Okay. Multiply A and C together and I get 12. What multiplies to 12? It has 7. Negative 4 and negative 3. I gotta watch those signs because it's got to add to negative 7 but multiply to positive 12. Alright, so let's set it up. 2x times x to the 4th minus 4x squared minus 3x squared plus 12. Remember, my goal is to factor this completely, and that means factor every set of parentheses until I cannot factor it anymore. All right, first two, what comes out?
X squared.
What's left?
X squared minus 4.
Oh, I see what's happening. What about the second two? Negative 3, what's left?
X squared minus.
Do you see what's happening?
No.
All right, look, what's happening? I've got this 2x outside. The common factor is x squared minus 4. What's left is x squared minus 3. The x squared minus 4 just so happens to be difference of two squares. That's correct. I'm out of room. I forgot to scroll back up, so I'm going to have to do a little arrow. Come on. It's thinking about it. Thinking, thinking, thinking. I'm still thinking. Some of them, not all of them, no. All right, so x squared minus 4 is a difference of 2 squares. X squared minus 3 cannot be factored any further. Are we all in agreement that this cannot be factored any further? It is factored completely. Yes, Isis. Not yet. Just the 3. Set every piece to 0. Evan, put that away, please.
Oh, that's.
There's actually, and this is part of the fundamental theorem of algebra. This number tells you how many solutions you should get. Okay? The biggest exponent tells you how many solutions you should get. Now, some of them might be imaginary, but... All right. 2x equals 0. X minus 2 equals 0. X plus 2 equals 0. X squared minus 3 equals 0. Watch. Divide by 2. There's 1. Yes. Add 2. There's another. Subtract 2. There's another. If I add 3 to both sides, what's the square root?
Negative. That's 2 solutions.
1, 2, 3, 4, 5. Yes.
We're writing it down. Can we just write plus or minus 2?
Yes, you can. You can.
How'd you get 5 solutions?
1, 2, 3, 4, 5.
Do we need to write down the solution?
Yes.
Right now, yes.
Oh, also, I asked another question.
Okay.
4.
What's your question, Justin?
Right there, the x squared minus.
Record. All right, I'm going to make it equal 0. I'm going to move the 6x to the 4th to the other side. It becomes positive. That's the biggest exponent. So I got 6x to the 4th minus 27x cubed plus 15x squared equals 0. GCF, do I have one? X.
3x.
It's 3x. It leaves me with 2x. Yep. 2x squared minus 9x plus 5. So now the question is, can I factor what's in parentheses? Does anything multiply to positive 10 but add to negative 9?
Yes. No.
I don't know.
Oh,
Negative 10 and
No,
1.
it's just.
Negative 10 plus negative 1 is negative 11.
No, negative and positive.
No, it can't be.
Then that would multiply to negative 10 and not positive 10. So this is one that cannot be factored, and I want you to see that. So now we've got to go back in our brains, because at this point it's factored completely, right?
Yes.
Well, I can set 3x squared equal to 0, and I can solve that by dividing by 3 and taking the square root. I get x equals 0. And by the way, this is considered what we call a repeated solution, because x, this is really x times x, so you get 0 as a solution twice. You don't have to write it twice, but it's called a repeated solution. Just if you're looking at the power of 4, wondering where the 4 solutions. You absolutely do. You have to go back to, how am I going to solve a quadratic that is unfactorable? And Sarah hit it on the head. It's the quadratic formula.
This is really fun.
It is fun, isn't it? I agree. Opposite b, plus or minus square root of b squared minus 4ac all over 2a. I hope we all remember from our lovely videos we created, we remember the quadratic formula with no problem.
I'm gonna be like 87.
Which gives me 9 plus or minus square root of 81 minus 40.
Yes.
81 minus 40 is 41. So all these chapter 1 concepts come back into play. There's 2 solutions plus my 2 repeated solutions for 0 give me my 4, and I'm done. So if you hit a quadratic that equals 0, Quadratic formula, if it won't factor.